I shall talk about digital audio effect. And there's a frequency range of instruments and some frequency range of instruments, and there are some audio spectrums. For instance, a synthesizer, according to the notes, should be about 5 Hz to very low to 8000 Hz. Piano, 75 Hz to more than 3520 Hz. I think I should be about 4186 Hz, and so on. So there are some concepts called bass guitar hypothesis and so on. Equalization, that means that each instrument should have its own frequency range, the instruments. Okay, so we have some basic filtering. There are some concepts. Basic filter and cutting and boosting, I think. The basic filtering is remove frequency range, attenuate, cutting, attenuate specific frequencies, and boosting means that enhancing some characteristic. Basic filter types. Now basic filter. It should remove some, there are some low pass, LP. We have here the center frequency, and that's minus 3 dB or something. We have high pass frequency, and again a frequency, cutoff frequency is called, and minus 3 dB here. And then we have bandpass filter with F low and F up, and this is called the center frequency. You know, the center frequency for bandpass filter is F low times F up. Okay. And there's some other things. I've heard of those things before, and some new things is called shelving filter. Sometimes it's it's about to gain or attenuate. Is gain and attenuate. Or here, gain and attenuate. It could be 18 dBs or minus 18 dBs. Yes. Okay. It should, yeah, and we have some ERR filter. It should be like is frequently used, and there's some difference equation I don't know about it, but I know it should be like this. The sum of difference, sum b1 xn, no, I take it here, should be output, should be like some consequences be constants x xn minus 1 and minus 1 and so on, and minus a1 times yn minus a, and so on, pop up. Yeah, so difference equation. Feed forward and feedback, forward and backwards. Yes. Cutting and boosting, it should be, the first one was in frequency rates. Here in cutting and boosting, this is shelter filters. And then there are some gain. No, the last one is boosting. It's something to do with some Q is a center frequency divided by bandwidth. And we have some, yes, we have some gain. We have some here, be like this. Okay, and we have some different Q equal to 1, or maybe Q to 4, and so on. Different types, and we can also have some, yeah. It should be there should be some gain near a distant specific frequency. Specific FRQ. Yeah. It should, for instance, 400 hertz here, and gain on Q4. This Q factor. There could also be another one where we have the FC is the same 400, and the G is 12, or maybe G is 6, and so on. Okay. And now let's continue with distortion. It non-linearity, because of non-linearity, and it creates additional harmonics. Could also be some intermodulation distortion, but here it's about at harmonicities. A change in the waveform of a signal, a change in the waveform, as a result of non-linearity. And there's some oversampling, and oversampling. Then we have here an xn, an input, and we have maybe some upper here, upper sampling, and then we have some maybe non-linearity, and then we have some gain. Oh yeah, and then we have some tone shaping, and then we have a down L, and then yes, we get the output. There should be some gain here, but it should be some tools that we make to make some distortion. Yeah. Distortion increases the bandwidth, and we have to avoid frequencies bigger than a half of Nyquist, above the sampling rate, because Nyquist theorem. We have to adjust this or to comply with this. Yeah. Frequencies above Nyquist frequency will appear in the spectrum in form of aliasing, and then we have to use a low pass filtering to go back again. We have some we can have some compression. In dynamic range, complicated stuff, yeah, and comp filters, combination filter. We can this, for instance, feed forward comp filter. It should be an xn plus some xn minus d. Some g is a factor less than 1, and d is a delay. Yeah, simulate. Yeah, and we can also have another comp filter with, we have this kind. Yeah. Yes. And an ERR filter, yeah. ERR, it should be UN is GXN minus D is forward minus G times Y N minus D. Well, it could be nice to have this. And then there's some reverberation. There should be a temporal diffusion. It's something a delta is called for division in for some function in 0 and maximum for tau. Same functions in where tau is different from 0. Yeah, we can get some revelation there. I don't have any more things. I don't have experience with it.